Hello, everybody. This is the building applications with Xamarin for iOS and Android using C# session. It is not actually the avoiding cloud fail, learning the mistakes from Azure that Mark Rusinovich was going to do. That's going to be in 1B. So, all right. So I want to ask first the audience, how many of you, it's a little bit difficult, but how many of you own an iPhone? All right, all right, all right. OK, Team Android? Team Windows Phone? Ah. All right, there seems to be some excitement. And who here is a C# developer? All right, F# developer? Nice, nice. We got a few of you. I also do F#. And VB.NET? All right. So F# has surpassed VB.NET. That is an interesting turn of events. The good news is that all of you can be mobile developers. Everybody that raised their hands, and we're very passionate about this subject because ever since the iPhone started this revolution of carrying this micro supercomputer in your pocket. It's not only been a supercomputer that you carry with you, it's a computer that connects you with anybody that you care about. It connects you to your family, connects you to your friends, and every once in a while allows you to engage in a Twitter fight with Justin. The one thing that we do know is that the mobile web is now, that mobile applications are no larger than the web. And this is only the beginning. People use more mobile apps today than they use the web. And we're only getting started. Recently, Flurry Analytics just published this data, and it's very interesting. The results of this data, they measure what people were doing on their mobile devices. And this is very interesting. People are spending 86% of the time using native mobile applications as opposed to browsing the web. There's a very big chunk of people that are just using it for gaming, people that use Facebook. But this is very significant. And in fact, the use of native mobile applications in the same report is going up year over year. So that is kind of a big deal. So the issue really is that what has happened is that people expect your mobile application to be a fantastic application. And among those things, you want applications that respond quickly, that integrate natively with the platform, that take advantage of what's in the platform. They don't want them to be laggy. You want the applications to work when they're connected, when they're disconnected. And you have to remember that people are going to use your application for a few minutes when they're standing in line, maybe at a restaurant, placing an order, when they're, it's filling all those empty spaces in their lives. That sounded horrible. No. When you're waiting for your cup of coffee at Starbucks, you only have a few minutes. You're checking what's happening on the network. You're checking your email, things like that. And you don't want the application to be slow. So, this is one of those areas where C# just fits like a glove for mobile development. I don't know if you guys remember, but Facebook a couple of years ago was a big proponent of using HTML for building mobile applications, and they went full speed ahead with their application. It used to be native, then they went to HTML, and this is what happened to the ratings of the application. It went very quickly to 1 stars. It was a terrible experience. At that point, Mark Zuckerberg made an announcement and said, we're now moving to native. We're going to build a native application that delivers a native experience. And this is what happened once they launched the native version. So they went from a majority of 1 stars to a majority of 5 stars. So it is a big deal. Many competent people have tried to make HTML mobile apps work, and it's just too difficult. And you're always constrained by what is possible in HTML. You don't really get to access every possible feature, every possible sensor, every innovation that Google Microsoft or Apple add to the operating system. So that is always a challenge that you have to face. So so as you can imagine, I'm a big fan of going fully native, getting access to everything that the platform has to offer as opposed to a subset. Now, I also believe that if you have a website, you should make it mobile accessible. So you should certainly make sure that every website property that you have works great on mobile. But when it comes to applications, and when it comes to engagement, and when it comes to competing, you really should go with native application. And people want applications like this one. You want applications that are very smooth, that respond quickly, that take advantage of the sensors in the operating system, that take advantage of the latest innovations from the platform in terms of animations, dynamics, physics, simulation. These devices have hundreds of sensors. Well, not hundreds of sensors. They have a dozen of sensors, and they have hundreds of APIs to take advantage of these things, from global positioning to the direction that you're looking into. So you want to create great developer experiences. You want to create, great user experiences without any limitations. So what is interesting, this is a sample of some great experiences that we've seen. And what is really interesting about each one of these applications that I'm showing here is that every single one of these native apps has been built with C#. These are non-native applications built in Objective-C or Java. They're all C# applications. So you can also, you can also build applications like this. It would be nice if a few of the guys that build these applications are in the audience, so we should give them an applause. They've done a phenomenal job. It's been fantastic working with them. So what I want to show you today is how to create your own applications. And keep in mind, now it's possible to run C# with, in my opinion, it is the state-of-the-art language. It is one of the most sophisticated languages in many dimensions, in the dimension where it's easy to add people to an existing project, because strong typing helps you grow your project in that dimension. It's a language that allows you to evolve your project over time, because you can maintain the code. You can read what somebody else wrote 6 months ago without wondering what the hell is this variable and what's the type of the variable. So it's a good programming system for scaling both in the team size and scaling over time, and also has a tremendous amount of features like async programming that allows us to focus on the experience instead of forcing us to be glorified accountants or bookkeepers. Anybody that has used languages without async knows that, for many years, or those languages, or C# pre-async, basically made us into bookkeepers. We're keeping state left and right. We were tracking errors. We did poor error recovery. So C# is actually really good. We are able to combine the best experiences of the platform with the best features of the language to do this. And you can reach pretty much every interesting device that matters on Earth today, personal devices. So from the Windows desktop computers to Windows tablets to iPads to Androids to Google Glasses to wearable devices. So it is a very large number. So what I wanted to show you today is how do we build these mobile applications, how we can architect the application. So I'm going to walk you through the process. A lot of people that went to the booth have been asking us, so it seems a little bit like magic. There's actually no magic involved, and I'm going to try to demystify what it takes to build a native application on Android and iOS. So let's start with the most common approach of how people build applications today. We call this the silo approach. Essentially, and this is how historically it has happened, you have a team that has to learn Objective-C. You go and build your application. It's a very nice application. And then the market, Android becomes very popular, and all of a sudden you have to spin up a separate team. Now you got a bunch of iOS junkies, and they don't want to touch Java, so you got to spin up a new team, and they're going to do a lot of Java code, and they're going to build your application. And then Windows Phone comes in, and you need to build the same thing. Right? So now you have 3 teams, each one working with a different programming language. And while this works, and certainly companies there's companies that have the budget that you need to make this happen, you still need to maintain 3 teams, 3 set of tools. You get problems with feature parity. You implement the feature, it's not on the other one. You upgrade the server, you didn't release it in all the platforms. You start running into, if you have 7 releases per year, now you have 7 releases across 3 different platforms, all with different levels of features and completion. So, and also, if you're stuck doing Java, you don't really get any of the advances that C# has done for the last 10 years. I think that Java just got lambdas last week or 2 weeks ago. There was a funny tweet that said the most popular query on Google right now is, what are lambdas, from Java developers. So, you know, they're getting there. And, you know, I think that Objective-C is a respectable language, but it's also a C language, so it's easy to crash, it's easy to, it's easy to make mistakes. So we don't want to go there. I think we can do better with C#. Now, the other approach, so this is a silo approach. You have 3 teams, you build 3 things. The second approach is what most people call cross-platform. So this is a term that annoys me a little bit, because when people say cross-platform, they're thinking some sort of write once, run anywhere technology. This is typically an approach where you use some kind of abstraction layer or some API. You use a single language, single set of API, and then a magic box. We call it the magic box. The magic box poops out an Android app, poops out an iOS app, poops out a Windows app, and you know, it is the lowest common denominator, right? So these things, pretty much by definition, are poor experiences. You don't really get a very good experience on these platforms. You just get something, and you know them, right? You've seen these apps before. You've tried those apps before. You know, you immediately can tell when this app was built with a cross-platform application. The labels are in the wrong place. The navigation is completely, that has nothing to do with the operating system. When the operating system upgrades, nothing looks the way that it's supposed to look. So this is what, so absolutely, we don't like that. Well, we don't recommend. You can still do it. And there's scenarios where you can do it. For example, if you have a captive audience, right, and they're forced to use your app, then you can ship anything to those people. Really, when there's no competition, it's a beautiful world. So you can do whatever you want. Our approach, on the other hand, is approach where you actually have to compete. And you're going to compete on quality, and you're going to compete on user experiences. The way that we approach this thing is you will have to architect your application in a way where all of your shared, all of the code that you could share across platform, like accessing a web service, storage, data synchronization, your business logic, you put all of that in a shared library. And we'll talk a little bit about the approaches that you can take here. And then you use C# to build an iOS app. You use C# with our iOS API, C# with Android APIs, or C# with Windows APIs to create native experiences everywhere. So most of you guys you're familiar with how you build Windows applications. The APIs that I have listed in the bottom, those are what we consider the core libraries, the base class libraries. So things that you can expect in a web app, or you can expect on a console app, or a server app, or on a mobile app, or WPF. This is the stuff that you can find everywhere. And that's the stuff that we recommend you use in your lower layer. And then you got the APIs that are specific to the platform. Of course, this list is not comprehensive. It's for illustration purposes. But you use specific APIs for each one of these platforms. So Windows Foundation, Windows Storage, and so on. So you guys are familiar with this. You started with .NET, and when Microsoft launched the Windows Phone, there's all these new APIs that you got to use for the phone. So we did the exact same thing. What we did is we projected every one of the iOS APIs that are endemic to the platform, and we projected all of those to C#. So you actually use C# APIs to access the native platform. We did a couple of interesting things here. We didn't just surface the API as is. We actually made it strongly typed. So one thing to keep in mind is that iOS and to some extent Android have frameworks that are built on loosely typed APIs. They're very similar to the APIs that existed back in the .NET 1 world before we had generics. So there's really no array of something. You always deal with an array of things, right? So you don't have arrays of views or arrays of buttons or array of labels or arrays of gestures or array of Bluetooth connections. You have arrays. And you extract data from the arrays, and you just hope that you got the right type. And you hope that the thing is what you expect. Right? So we did a little bit of work there to make sure that all of the iOS APIs are surface, but also that are strongly typed, and that they use all of the .NET idioms that you guys are familiar with. We did the same thing with Android. And again, you keep all the baseline APIs, and now you have to use a new set of APIs. So the way that you should think about building applications for iOS or Android using Xamarin is as if Microsoft had just introduced a new database access layer, right? So you just got to learn the new API, and you start using it. That's really all there is to it. Give or take one or two things. So the way that this works is we have a C# compiler and an F# compiler. We have a full .NET runtime that you can run on Android and iOS. iOS has a little limitation imposed by the security system in iOS, which is you cannot JIT compile, so you cannot generate code dynamically. What this means is system reflection emit, forbidden. You can't use that. Very similar to Windows RT or Windows Store. Then we provide these projections that allow you to access the native UI layer. And in the case of iOS, we use a static compiler. So we go from C# to MSIL, well, CIL, and then we take the MSIL code and we generate native ARM code. That's it. So what you actually ship is indistinguishable from a native application. You can either feed it through the Mono code generator, or you can feed it through Apple's LLVM code optimizer. So it goes through the exact same code optimization engine that Apple's Objective-C and C++ goes. In the case of Android, we're a little bit, we are able to take advantage of the fact that Android doesn't impose these limitations, so you have full access to the JIT. So this is the platform that feels the most close to regular Windows development. So think of iOS as WinStore kind of environment, and think of Android more as Windows forms. No, well, yes, roughly. All right, so what is important for you to remember is that anything that can be done with Objective-C or Java can be done with C#. So there's really no limitations on what you can do. And what I'm going to do now is I'm going to show you a little bit, I'm going to show you how to build an iOS app. It's going to be a quick sample, and it will give you a flavor for the sort of APIs that exist there, and a little flavor of iOS. So if we could switch to my Windows machine, yeah, that's perfect. So this is Visual Studio, and I created a new project. I just did File New. This is the project, and I'm going to get started with the designer. Now, there's only so much that you can do on a presentation when you have a lot to cover. So all I'm going to do here is I'm going to create a quick user interface with a couple of buttons. And the idea is we'll take a picture, and then we'll share it on Twitter. And we're gonna apply a couple of effects to the picture. So let me get this puppy here, right there, and then I'll align this guy over here. Yep. How do you view properties here? View F4? Oh, that is nice. All right. So let me get this thing. How do I make it? All right, there we go. So take a picture. And again, this is not the kind of native experience that you want, but this is just what we are going to be able to do here. So share on Twitter. It's very similar to the designer that you've used in the past. You double-click on the thing, and it goes and inserts a method for you. So I'm going to walk you through what I'm going to do. First, I'm going to create a UI image picker. This lets you either take pictures from a camera or lets you pick pictures from the storage on the device. Since I'm going to be running the simulator, I'm not going to actually use the camera. So this is what you do. And also, I apologize. I didn't know that we're going to end up in this room, or I would have done code snippets. So also, since we're not animals, we're going to use async programming here. So now, this would be enough, and this would show me an image selector, right? But let's do something a little bit more interesting. I actually need to, the image selector actually triggers a number of events. So I'm going to, in this particular case, say, whenever you're finished picking media, there's all sorts of events. So I cannot just wait for the picture to be taken because I might get different notifications, so I need to hook up to events. So I'm going to, I'm just going to stop this out. And the one thing that I need to do after the user selects a picture is to dismiss the, and again, we're not animals. So I'm just going to do this, and I'm going to say await, dismiss, view controller, async. And maybe we'll use a parameter, maybe not. But the first thing I need to do is let's just remove the UI. So what this is going to do is when I click on the button, it's going to present me with a picture selector. I'm going to select a picture, and then when it's finished, I'm going to dismiss the window. That's what I've done so far. Now, let's go back, and let's go back here and implement the code for Twitter. So the first thing I'm going to do is I'm going to save the image here. So UI image. And I'm going to do a little bit of checking here. If the image is null, I'm going to show you how you provide an error message. So I'm going to say alert equals new UI alert view. And I'm going to say, whoopsie. You need to take a picture first. And then I'm just going to show that alert and return. That's it. But if I have an image, I want to tweet that image. So let's go here and say, using monotouch, I'm going to use one of the iOS frameworks. It's called the Twitter framework. This is part of iOS. This is not part of our product. This is just a one-to-one mapping where anything on the monotouch namespace is just an Apple API. So I'm going to say here, Twitter equals new TW tweet compose view controller. And I could add some text, but I'm going to let the imagination run wild in this case. And all I'm going to do here is I'm going to add the image that we took a picture of. And just like before, again, we're civilized people. So we're going to await present view controller async. And we're going to show the Twitter. And then we'll figure out if we want to do something else later on. So if I were to run this application, let's give it a shot here. Where's this? Here we go. All right. I forgot that. Let me get this. So what this thing is doing, it's compiling the code and running on device. So this is my beautiful UI. And let's try to share this on Twitter. Well, I haven't selected a picture, so I get this gorgeous message. It's amazing, I know. Now, I'm going to take a picture. So I'm going to say, yes, you can allow access to my library. I'm going to take this picture of the tower, Eiffel. And whoa, this is horrible. We have a bug. Oh, no, we don't. It's very easy to fix. All right. So the first thing that we did is, while we did get the picture, we didn't really store it in the image variable. So let's do that. Let's do that. But it would be just too lame to just store the image, right? So let's get the image. Where do you get the image from? Well, you get it from these event args that you get for the event. So I'm going to say e dot, what is it? The original image. That's what I want. So image, let me call it TMP for now. So this would not be very interesting if I just tweeted that picture. So let's spice this up with a little library called core image. This is a native library in iOS. It's a high-performance native library that contains a lot of image filters. These image filters are actually powered by the GPU, so you can actually have the GPU on the iPhone perform all of these filters. And what is interesting about Core Image is that you construct a recipe. So you say, I would like to apply a filter, and then connect the output of this filter to this other output of the filter, connect it to this other thing. So you can chain a number of filters, and then you upload the recipe to the GPU, and it executes on the GPU. And the output is the image. You don't have to worry about all this GPU nonsense, but what is important is that you're not sending the image back and forth for every step of the process. So it's incredibly fast. You say, this is my image, this is a configuration, now do it. So I'm going to show you how to do that, because we've done a really nice binding to C#. We've made it very, very nice to use in C#. So what I'm going to do is I'm going to first add a vignette effect. There's hundreds of effects. We can go to the website and look at that. But what I'm going to do is I'm going to add a little bit of vignette effect, and then I'm going to put sepia on that. Throughout the talk, you'll see that I'm a big fan of vignette effects, so and sepia. So I'm going to take this guy, and here's what we're going to do. The way that it works is that you have to configure the image. So I'm going to say CI image from CG image, and I'm going to say the tmp.cg image. Just, you don't need to know how this works, but basically, I'm converting it from one format, from the UIKit format, into the format that Core Image can consume. Now that I have the vignette, I'm going to apply the sepia filter. So it's just CI sepia. And you can see that there's a bazillion of these filters there. And the image is equal to the vi.output image. This is, this is how I'm chaining the recipe. This is how you configure the recipe, and you chain one effect to the other. Now, the vignette is actually not that interesting on its own if you just do it that way. So let's configure it. And I have a bunch of properties here. This is one of those areas where C# really shines over Objective-C, because we've strongly typed the entire API. You get code completion for these things. It knows what things you can do, and you're only allowed to put the values that are valid. On Objective-C, it's a little bit like JavaScript. You can throw anything its way, and maybe it'll work, maybe it won't. It's anybody's guess. It's just a dictionary, and you can't really track down bugs. I mean, you got to inspect every single property, figure out if you got the right value, the right constant. So with strongly typing, we let the compiler do all this work for you. So I'm going to pick radius, and I think I'm going to do 10f. And I think there's an intensity here, so I'm going to do 2. Actually, I'm going to need a 10f, just a 10 and 2. So now I got my now I got my recipe. Now to render the image on the GPU, you say new CI context. Oh, that's not what I wanted. CI context. And oh no, that is not what I want. I want the constructor that allows me to specify that. So let me do CI context from context. No, from options. That's more like it. And it takes a CI context options, as you guys can see. And again, this is some very nice work that we did on strongly typing the API. So again, I can get here what I can do. And in this case, I'm going to say use software render. I'm going to say false, because I want the GPU to do the work, right? So instead of doing it by software, we'll have the GPU do it. All right, I think we're almost there. Now, to actually run the pipeline, so to actually run this recipe, what I need to do is I need to call context, get CGI image, it's something like that, create CGI image, and I need to pass the CGI image. So what is the image that I'm going to pass? Well, I'm going to pass the sepia output image, and then it wants a rectangle, so I'm going to say whatever is the size of that API, of that image. All of this actually is very well documented in our docs. So let's, what is the return of this thing? That it's a CGI image. CGI image. And what I'm going to do is my global variable that I stored somewhere is just going to use this thing. So if everything works as expected, as I hope it does, this should now have a nice vignette and a sepia filter applied to it. So we compile, we run. So I'm going to take a picture. And maybe we'll go with the cat. Which one will be more obvious? The tower. The tower is fine. So when I share on Twitter, you can see right there. I don't know if you can see it. Can you see it? Yeah? Nice, nice. For some reason, there is a tower at build. Very odd. All right, let's just get that thing sorted out. So that is just a little bit of a taste of what you can do with iOS. As you can see, I'm still using C#, and I'm using this new universe of APIs that are bindings to the underlying platform. And of course, we have a UI designer that you can use to, this is very popular among developers. You drag and drop stuff, and you put together your UI. So let's go back to my slides. Let's go back to my slide and take it from there. Let's go. Oh, there it goes. All right. Sorry about that, guys. So let's talk a little bit about what strategies you can use to share code across platforms. So what you just saw was pretty much unshareable. It was all iOS. It was all native API. So let's see, what can you do? So let's remember what we were saying at the beginning. You want to have your shared API at the bottom, and then you're going to have your per platform code built on top of each one of those. So you get a couple of options. You can put your business logic as a shared project, or you could use the new universal app setup, or you could use a PCL library. The details are not important. We'll talk about that in a second. But what matters is that you'll share the code, and then you'll have platform-specific code on each one of those. This is some information that we wanted to share with you. In practice, this is data from real applications from our customers, the Calc application, iCircuit, and TouchDraw. And the dark surface represents the platform-specific code that was written for that platform. So as you can see, it's not a complete grid because not every app runs on every platform. But you can take, for example, you can look at the columns or the individual applications. So the Calca application, which is a fabulous, amazing calculator. It's an algebraic calculator for the layman. Works on iOS, Mac, and Windows Phone. And what is very interesting is that iOS actually required a lot of platform-specific code. So you can see that the code sharing there is not very big. It's 23%. There's 23% of specific code for iOS. And actually, on the Mac, the platform-specific code was very little. And that is because macOS actually has very powerful frameworks for dealing with documents. So it handles creating documents, saving documents, storing them in iCloud, synchronizing them, undo. It does all kinds of things for you. So you don't need to implement a lot of those things. But in iOS, you have to roll out some of those things yourself. TouchDraw is also a very nice app. It's a vector drawing app, very similar to Visio, but it runs on Android, iOS, and Mac. And this application shows more of a typical, it's not line of business, but it's a typical high-end app. And you can see that in some cases, you only have 28% of native code, 39% for iOS, or 24% for Mac. And actually, if you use, there's certain frameworks, in particular for line of business applications, like MVVM Cross or Monocross. And if you use those frameworks, your code sharing can go through the roof. You can write all of your code in an MVVM way, and you almost never have to do native code development. So you need to put a little bit of glue. So it really depends on the spectrum where you want to go, full native experience or a little less, right? So it's really up to you. Now, Universal Apps is something that was introduced recently. It's just a very nice mechanism for you to set up Windows Store and Windows Phone applications. If you have the new Visual Studio Drop, you can use it directly with iOS and Android. So you just add iOS, Android, you reference the shared project, and off you go, off to the races, and you can use the same features that you have for those two platforms, and you can extend it to iOS and Android. It is available on the new drop of Visual Studio 2013, and it's coming soon to Xamarin Studio. We've already have implemented it. It just happens that it is implemented in our next release, which is coming in about 5 or 6 weeks. So that's one approach. You can go the universal route approach. The second approach that you can take is you can use the portable class libraries approach. And this is the place where instead of trying to share code at the source code level, you just use binary drops. You use binary libraries, DLLs, and you can either go the pure route of celibacy. I call it the celibate approach, where you don't touch anything platform specific, and you can pass around this PCL. This PCL works. I'm sorry. You can just share this PCL, and it works across all platforms. You don't have to do any extra work. Now, the problem with this approach is that it's like being celibate. It has a few limitations, and you don't go out on Fridays. You don't hang out with certain people. So I really like this thing. I don't think that there's a name for this, but there's an advanced use of PCL that is a little bit nuanced, but it's incredibly powerful. And I just call it the advanced PCL version, but I'm sure that somebody at Microsoft will correct me. And it works this way. Provided that you stick to a public API contract that can be compiled by a PCL profile, it doesn't matter what you use behind the scenes. So what you do is, instead of creating a single DLL that works across all platforms, you create what is called a reference assembly. And the reference assembly can be used everywhere, and that's what you reference. Your project references that, and you can use it on all of your portable class libraries. But the actual implementation, you have one specific implementation for iOS, one for Android, one for Windows Store. And this is how Microsoft implemented their this new PCL that they released for SQLite. This SQLite implementation has very different implementation from Windows Store and Windows Phone. And we are working on contributing iOS, Android, and general Unix support to that. And the way that we're going to do it is we're going to have these per-platform implementations that behind the scenes are doing all kinds of platform-specific stuff, but they abide by the public contract. So I am a big fan of this system. I don't know what it's called, but it's being used in a few libraries already. And you can notice those because those are actually PCLs that are distributed as NuGet. So the trick is always you use NuGet with PCL. If you guys have not seen how to create a portable class library, you go to File, New, Portable Class Library Project, and provided that you have our products installed, you'll see these two little guys at the bottom, Xamarin.Android and Xamarin iOS. You click those two, and you can create a portable class library. This particular profile that you see there is our favorite one. We call it Profile 78. Well, Microsoft calls it Profile 78. Nobody understands why these numbers exist at all, but it happens to be 78. We just memorized 78. And this is our favorite profile. It gives you tremendous amount of reach. The only downside is that it doesn't support Silverlight 5. So for all of you that are still using Silverlight 5, it's a little bit of a problem, but I'm sure you guys will survive. So I can tell you that most of the work that we're doing at Xamarin, of the new libraries that we're introducing, we're making them all compatible with this Profile 78. And that includes our SQLite data binding. The Microsoft one is like a very raw, direct access to SQLite. Ours is a system data version of SQLite, right? So you get data column, data row, data whatever, all that stuff, right? We just ported Couchbase that we contributed today to the .NET Foundation. So we took the Java code base and we ported it to C#, and now you can have disconnected operation that allows you to synchronize your data whenever your mobile device goes back online. It has support for synchronizing and dealing with conflicts on synchronization. So it's an incredibly powerful storage and synchronization technology. And it's a PCL in our case. We're also doing system drawing. System drawing, that API that was so popular back in the Windows Forms days. It is sad that there's nothing that replaces system drawing even today. So we're bringing system drawing to iOS, Android, Windows Phone. So that will give you a very good spread of APIs for drawing into the screen. And this is one of those. Yes. Yeah, I never understood why Microsoft didn't continue supporting system drawing, because it's a great API. But we're bringing it everywhere. We're bringing it to Windows Phone as well. So, and we don't work for Microsoft, which isn't nice. But system drawing is one of those where we're going to have to use this advanced PCL system. We're going to have to do very native and specific things. In fact, if you go to GitHub today, you can see that our system drawing implementation for iOS is entirely built on top of core graphics, of Apple's core graphics. So if you use our system drawing API, it goes through core graphics and then to the native system. If you go to Android, we use a library called Cairo. And if you go to Windows Phone, we're also going to use Cairo on those two. Then there's a library that one of our team members built, which is an absolute delight. There is nothing like this in the world, and I think it deserves to be recognized. There is no library as fast or as comprehensive and as well designed for handling email and my messages as MailKit and MIMEKit. It beats the C implementations. It is very interesting. This is a C# code base that beats every existing C implementation. Perhaps because it's better designed, but it is very impressive. If you ever had to do email and you faced all the problems of sloppy implementations, poor implementations, incorrect IMAP implementations, hacked SMTP servers, you don't need to deal with that nonsense anymore. MailKit and MIMEKit are very young, but they're developed by somebody that built email clients for almost 8 years. So he knows his business, and we've also contributed that to the .NET Foundation. So you should be able to get that thing out of your system. So now, during the keynote, I showed the Xamarin Store app, and it's a reference application. It's a reference application that shows you how to build a cross-platform application. So I'm going to show you a couple of items. I'm going to show you a couple of things from this app here on my Windows machine. So let me just open that up. Where did I leave this? OK, here it is. And this uses some of the practices that I've been mentioning here. Let me just have this finish loading. OK, there we go. So we use the same approach where we have all of our shared code here. Let me click this away. All right. Let me get rid of this thing. All right. So this is our project. All right. Whoops. All right. So this is an overview of our project. The shared directory contains a solution that contains all the shared code. If you download this from GitHub, there's two versions. One uses a shared project and a shared files, and the other uses a Pico library. So you can take a look at how you would implement either one of those. And here's all your data. So it has the data for a file cache, Gravatar, web services, cute little things, the model for all of the information that we have, country data, order, the product, and so on, and an implementation of the Xamarin single sign-on. Remember that you had to enter the Xamarin address so you could get your T-shirt. Well, we use this to retrieve your address and and validate your password. So all of this data is what lives in the shared directory. And like I said, there's two ways. There's a branch that uses PCL. There's a branch that uses the shared project. We just had a conference last week, and we partied too hard. Sorry about that. Now, this is the Android version. And what I showed you in the keynote was iOS. But let me show you. We have a nice effect, the Ken Burns effect. I don't know if you guys noticed it, but it was when you're, well, you guys probably didn't notice, but when you're looking at the product, the image is actually moving very slowly in the back, like that. There's a cinematographer called Ken Burns that uses this effect, so we implemented that. And let me show you, where is this thing? Resources, layout, here we go. And these are some of the, this actually is just, is our Android designer, so you can take a look at a couple of the screens for Android. In my opinion, is not as beautiful and pristine as iOS, but it's there. We have an Android designer, so if you want to build your apps, you can build them there. And then finally, the iOS version, which is what you saw today. I already showed it to you guys. And in this particular case, this is what we modified during the keynote. Of course, you guys don't have Roslyn, so you don't need to use French codes. You can just put your email address there. And yeah. Let me just start it up for you guys to enjoy the beautiful Ken Burns effect. Oh, look at that! And these guys are actually work at Xamarin. So let's take a look at this. Let's do that and check out. And again, I'm going to run into the issue where. Oh, I didn't show you the Ken Burns effect. OK, so just pay close attention. Can you see that? Do you guys see that? I apologize, guys. All right, and again, I'm not going to get away with ordering this today. So let's go back to my slides. I have a couple more things to tell you, and then maybe we'll have time for a quick Q&A. To make it simple for you guys to quickly get up and running, so yes, we got you all the Android APIs, and yes, we got to the iOS APIs, but there's a universe of things that you want to use, like in particular, there's a lot of iOS components, a lot of third-party iOS and Android components. It's a universe of things. So what we've done is we've curated the best iOS and Android components, as well as we had a bunch of themes to style your application, so you can give like a dark look or a retro look to your application. And all of those are available directly from our IDE. Just go, there's a special directory called components. If you double-click, you can get that. We support Android, iOS, and Windows, although some components are iOS-specific or Android-specific. And one of the things that we're very proud of is our support for a couple of interesting things that Google has been doing. I have my Google Glass here, and I'm just gonna, I got the Google Glass because, well, we're a mobile company, so we got to support this thing. So I had an excuse to tell my boss, hey, I'm gonna order one of those things. And the problem that you have with Google Glass is that you kind of sound like an idiot, because you go like this. You go like this, and you go, OK, Glass. OK, Glass. Take a picture. Damn it. OK, Glass. Take a picture. All right, good smile, guys. So the problem with this is that you're in polite conversation, and they hear you say, OK, Glass, take a picture. And what do they think? It's like, wow, this asshole. So I figured, this is not me. This is not me. OK, Glass, take a picture. What is this nonsense? Could we switch just for a second to back to my computer? So I want to show you what I did. I built this application. Well, it's called Nailed It. It's probably not the most tasty name, but what I did is I built this application. It's actually 3 activities in one. It's called the Nailed It activity, the Capture the Moment activity, and the Immortalize the Moment activity. So that allows me to be more myself. I can be, with people in a cocktail party, and I can just go, OK, Glass, immortalize the moment. And and it was a quick hack. It was a quick hack, but it takes a picture, makes it black and white, and then I have another one, which is one is immortalize the moment, so that will go into sepia. As you guys know, I'm a big fan of sepia. And the other one is capture the moment. That's black and white. And the other one is nail it. So you just go, OK, Glass, nail it. So it takes a picture and puts a big stamp that says nailed it. not very useful, but it makes me flow like a bird among my friends. So let's go back to our slides. We're also very proud of the Google Wear support because Google came out with Google Wear, and by the afternoon, we had documentation, samples, videos, training materials. My team really, I think I was having dinner with Nat, or we were, some kind of nonsense, and somebody was like, hey, should we do this? Like, yeah, sounds good. And by the night, they had everything done. Everything was ready, and Nat said, hey, we probably should blog about this. I was like, oh, the blog is already up. So. Anyways, congratulations to my team. They did fantastic work getting Google gear out. Now, let me talk about the last thing before we do a quick Q&A. But one of the challenges with Android is that there's so many of them. The fragmentation on Android is fantastic. So some people might think, well, that's a disaster. And some people are thinking, well, that's a great opportunity. So we're on the second bucket. And what you see there are actually not all of the screen of the form factors. These are only 23 out of the 27 form factors that Samsung ships for Android. And this is great news for us because we actually ship a product to help you target all those devices. So Android ships, there's 5 major versions of the operating system shipping in these things. They use different skins. They don't use the same version of the operating system. So we built a product to solve this problem, which is called Test Cloud. And what we do is you build a test case either using Ruby on Rails or Ruby, not Rails. No. You use Ruby to write your test case, or you use C#, right? You write a unit test, and you upload those to our server, and we'll run that on 750 devices. Now, I know that sounds like a lot, but we still need to add another 250 to get better coverage. But we run it on a cloud of devices, and we will run your tests on all of those things, and we'll report back the results. In fact, it is so useful that now my team is using it whenever we make a dangerous optimization. So in the past, we're like, well, we'll do the dangerous optimization, we'll send it through QA, and maybe a customer will complain, and we'll do something about it. And so recently, we actually used this product and say, well, this patch looks fine. I mean, it looks fine. Everybody reviewed it. It makes sense. Let's go ahead, but it's a little bit risky at this point in the release process. Why don't we send it through Test Cloud? So we send it to Test Cloud, and it turns out that out of 300 devices, it fails in a particular GPU. So there's a particular set of GPUs where this optimization failed, and it's spread out across a couple of devices. So we were able to identify the bug before we released it to the public, and we were able to basically blacklist that GPU before we ship the product. So it's been very useful for us. And finally, I want to close with with a thought. You can become a mobile developer today. You can get started and get a feeling for the iOS and Android APIs today by downloading the Xamarin Shirt app. That is the app that you saw in the keynote. You make the change, and you can also get your own shirt. So we have a couple of minutes for Q&A, and there's microphones with the 1, 2, 3, and I guess 4 microphones there. Thank you very much. So we have no questions.
Hi. I have a quick question for you.
Yes.
So I'm in the camp of the 3 silos. Everyone does their own thing, and I'm wondering for a third-party library which is completely made in for iOS, all Objective-C.
Yeah.
And I want to use it. I see that you have some really nice, connected to Apple's libraries, but third-party. What do you guys do in terms of support for that?
Yeah, so what you do is there's a thing called a native binding library project. And all you have to do is all you have to do, you have to create one of these library projects, and we have a tool that helps you bootstrap. And what the bootstrapping process does is basically it helps you bridge the Objective-C idioms to .NET idioms. Because Objective-C has a funky way of naming methods. So, for example, the finish launching is actually called application : finish launching : options, right? So what you need to do is you end up with a document that has all of these names, and you need to say, I want to translate this name, and this is the name that I want to give it in C#. So you need to create one of these projects, and once you create that project, you can access all the functionality there. In fact, if you want to get a taste of what it looks like, if you go to github.com/mono/monotouch bindings, you can see about 60 libraries that we've done that process. So you can use that as reference material to see how it's done. But that's how you do it. You have to create this connector that basically says these names in Objective-C need to be mapped to these names in C#, because otherwise it just looks very ugly. It would be very, very bad. And you do the same thing with Java. Basically, you want to name them in ways that are similar to .NET Foundation, .NET Framework design guidelines. Or you cannot do it and just end up with the ugly names. I mean, you can certainly do that too. So, but you can do both. You can do both. And in fact, the tool that we provide will already apply most of the .NET Framework design guidelines changes for you. So by default, we'll give you a good, decent change, and you can turn it off or just go super bad. Yes?
I'm just wondering what your dev environment is there. Is that Parallels?
Oh, I'm using VMware Fusion. Is just because then I can show the simulator back and forth. I have Parallels, but I alternate between the two.
Okay.
It's just this is the machine that I had set up. Yes, on microphone 2?
So my question was, during the keynote, I think we saw a universal app that ran on iOS. You didn't really mention that today, but does that work?
Yes. Yes, that shared thing is the universal thing.
But can you do the UI?
No. There is some confusion there. The UI you still need to do per platform. What you do is you share, you create a universal project, and then you have the shared code base, and then you have the per platform code. So yes, you have to use the native APIs. It just happens that Windows Phone and Windows Store now have very similar APIs. They are like 90% similar now, or something like that. I can't remember the number. That make sense? All right. Yes, number 3.
Hi. One struggle I always have with customers explaining, be it hybrid or Xamarin, is that there has to be an underlying knowledge of the platforms that you're building for. Whereas a lot of the marketing is easily confused to business people versus technologists that, oh, it fixes everything. I'm only using C#.
Yeah.
How do you have that conversation with people kind of explaining that really your .NET developers need to learn iOS idioms and Android idioms and et cetera?
Like you, I'm a technologist, so I explain it the way that I explained it here, which is, imagine that Microsoft has ADO.NET, and tomorrow they do Link to SQL, and tomorrow they do Entity Framework. So I explained it that way. You choose one of those, and you use one of those APIs. It is essentially that. It's a new API. You know, give or take, because I have emulators and things like that, but it's a different API. Now, what our team that engages with customer does, it depends, right? Because managers really don't understand the difference between ADO.NET and Entity Framework. So you gotta kind of explain it as it comes.
Yeah, the hard thing I found is for people from a staffing perspective, they all of a sudden assume, well, I'm going to take my services devs who knows C#, and all of a sudden they're mobile developers. But as you can see in all the demos, it's like
it's a very good point. It is a very good point. But actually, we've been very, very successful in bringing people that have existing C# experience, even ASP.NET people, and bringing them over to Android. I mean, it is incredible how quickly this thing is. In fact, yesterday, somebody on Backstage was telling me, like, I couldn't believe it. I couldn't believe it. They told me, use this thing in Xamarin and the Azure Mobile Services, and I thought it's going to be a disaster. It's like, no, it was up and running. I can't believe this. So, I mean, it was nice to hear this from a web guy. But we hear this all the time. Yes?
So I was very interested to see the system drawing thing. I was one of the ones clapping. Is that out yet? Because I didn't remember hearing about that.
GitHub.com/mono/system-drawing-core graphics.
Excellent. And why not Cairo on iOS as well? Is core graphics just faster in some areas and you decided to go with that? Or?
smaller binary download. That's
Okay.
it. So
Okay.
what happens is that on iOS, we get to access core graphics, and it's already there, and it does everything that we need. On Android, on the other hand, we don't get direct access to Skia. Google reserves the right to change the API to Skia. So you have to go through the Java layer. So basically, and the problem with Java is that Java doesn't have structs. They only have classes. And the problem of only having classes versus structs is that when you call methods that need a point or a rectangle, which is everything in system drawing, you create bazillions of objects.
Yeah.
So you draw a little map, and all of a sudden you created 20,000 objects on the heap. So the problem that we have with Java is the tremendous amount of junk that gets created. So we can't really use the C++ API that Android provides. We need to go through the Java API, which is very bad. So instead what we did is we said, we're not doing that. We're just going to go straight to Cairo, which is high performance. We use structs. We don't generate any garbage. And you pay the price of the executable size.
Excellent. Yeah, that's really great. I looked at this a little while ago, and there didn't seem to be a common library that we could use from Xamarin that hit all those platforms.
We're getting there. We're getting there. It's not finished, but we're getting there.
Awesome.
Yeah. Thank you. And the last question, and we're going to go?
Yeah, as a big Windows Phone and XAML guy, I'm really a fan of using MVVM.
Yes.
There are possibilities within Xamarin using MVVM Cross, for example, but what's your opinion on using MVVM frameworks?
You know, I like them. They're fine. You know, for some things we use MVVM frameworks, and you'll see a bunch of our samples use them. For others, we just man up and, you know, we'll just link files. Now that universal apps are out, this is going to change the space because it's so much nicer to use them. But use whatever you feel comfortable with. I don't have a strong opinion on MVVM. I like it, and for something it's great. So if it works for you, and in particular for line of business apps, it's incredibly popular. So if you like it, just keep using it.
Okay,
All right.
thanks.
Thank you very much, everybody.